Okay, let's talk about derivatives. Before we do this, I suggest that you do a quick recap and review slope and limits. So, what is a derivative? Well, if you had a function f of x, and then you just plotted point x on that function, what a derivative is that's how you find out how changing the input x a little bit to the left or right will affect the output f of x or y. So that's pretty much just determining rate of change, and we have a word for that. We should know from algebra that that is called slope. So we're going to do a quick review over slope. Okay? So I'm going to do an easy graph here. If I were to draw out the function y equals x, and I told you to find the slope, well, that should be pretty easy for you. This is a very basic elementary function, but it'll help, okay? But you should know that you just plot 2 points, because, you know, to find rate of change between, you have to have those 2 points, okay? Because that's what slope is. That's how you find it. So we're just going to call this x1, and this point is going to be x2. So the output is going to be y1, and this output's y2. Okay? And we should know that, you know, just to find the slope, well, first of all, we know it's going to be 1. It's just basic that way. If you just do y equals mx plus b, you know, it's just 1. But let's say we don't know that. We would know that we're just going to draw a line out. Okay, you just go up and over, or you can go over and up, okay? And we know that and so we know that the slope formula is going to be this over this. So if we're just going to call this v, and this is going to be h, okay? And we know that slope would equal v over h. So what is the slope formula? Well, you should know from algebra that the slope formula is m equals y2 minus y1 over x2 minus x1. Okay? But for the sake of what we're going to be doing later when we get into derivatives, let's rewrite this function. I really don't like writing it out this way, so let's rewrite this. Okay, let's rename these. Okay, so we're just gonna make y2 equal f of x2, y1 is going to be equal to f of x1, sorry, x2 is going to equal x plus h, and I'll explain that in a moment, and x1 is just going to be equal to x, which means y2 is going to be equal to f of x plus h, and y1 is going to be equal to f of x, okay? And like I said, I'll explain this in a moment. So what the slope function is going to be changed to is we'll just write it as f of x plus h minus f of x all over x plus h minus x, and these x's cancel out, so that just equals f of x plus h minus f of x all over h. That's going to be important to remember, and it will be nice to use. Okay, it's just a lot cleaner this way. And like I said, I'll explain this in a moment. Okay. So, if I were to draw some other function, okay? Some function y equals f of x. And I said, let's find a slope. Well, what's the slope of this function? I mean, you could just plot out some points, okay? Let's just do that. So I try to plot some points, okay? This is going to be x1. And this is going to be x2. And so this is just going to be f of x1. This is going to be f of x2. Because remember, y equals f of x. Okay? So how do you figure out the slope between these 2 points? Okay? I mean, well, we could just do what we did for the other slope and just draw, you know, go up and over, you know. Let's try that, okay? Let's go up and over. And this does work, I mean, it does, okay? You know, you're going to get some kind of rate of change between these 2 points, okay? And I'll just draw that out right now. Okay. And this line right here that I just drew is called a secant line. Okay? But how does this tell us the slope? Because you're saying that this point just goes straight to here, but really it goes all the way down here. You could have, you know, you could have a point here, you could have a point here, 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 and that's what we're going to figure out, okay? If you were to zoom in on this point right here, you know, because this is differentiable, if you were to zoom in close enough, you would find that it starts to kind of even out into a straight line. Even though it's a curve here, it would start to kind of straighten out, okay? And to find the slope there, you have to have 2 points, right? And like I said here, we made x2 equal to x plus h. Because really, if this was just x, then really what is this? This is really just x plus some number, which is h. So this is going to be x plus h. Okay? Now, how does that apply to this? Well, if we said this were to be equal to 1 and this equals 2, if we were to move this down, that would mean h equals 1 right here. So if we made h a lesser value, that means output would closer to f of x1 and x of x2. x2 would be closer to x1. And we would notice that the slope gets a lot more accurate. And we are going to find a much more accurate point here. And, I mean, when you're doing derivatives, though, you won't really have to think that way. Although it's important that you do for now. But eventually, when you differentiate one point, you find the derivative of one point, or you're going to find is you're going to approximate like that slope right here. And you're going to get a line like this, which is called tangent line. Okay? So let's try to figure out how we're going to find a tangent line, the function, so we can find the tangent line of every point on that graph. And that will give us our derivative. First, let's talk about how we're going to notate this, okay? If we're going to be doing like work or something, you know, if we're going to solve problems involving a derivative, we would write d dx f of x. Okay? However, d dx f of x is going to be equal to f prime x. The derivative of f of x is f prime x. So what is f prime x equal? And remember, this can be any function, just anything. Well, like I said here, we're going to be trying to find the slope. And we renotated it this way, so let's put that in, okay? But like I said, we have to have 2 points. 2 points to get to that slope. You can't have 1 point to find a slope, you know. I mean, yes, to find a tangent line you can, but to find that slope there, which is what you're really looking for, because you're looking for how it would change if you wiggle the value a little bit. So you're going to have 2 points you're dealing with. How do you make x2 as close to x1 as possible, but not making it equal to x1? Well, let's make a table really quick. Okay? Let's make a table. For now, let's just say for now that x equals 1. Okay? And we're going to start plugging in values for h, and then the output will be x plus h. And we're going to try to get this as close to x as we can without actually equaling x. So if we were to plug in 1 for h, then x plus h would be equal to 2. So yeah, we're getting pretty close. So let's try some more values. We do 0.1, then we get 1.1, 0.01, we get 1.01, 0.00001, we get 1.00001. Then we're just going to write 0.00 .01, and then we get 1.00 .01. Okay, we are getting very, very, very close to 1, to x. This is, you know, these numbers are getting so close together that it doesn't even matter. They're pretty much 1 point, but that's what a derivative is. We're trying to move it as little as possible. Just very small changes. How is that going to affect the output? Well, let's try doing something. Let's try plugging in 0. Wait, then that just be 1. But it can't be equal to x, okay? We can't have x plus h equal x, so it can't equal 0, okay? So it also makes sense here why h wouldn't be equal to 0, because when you plug it into the slope formula, you can't divide by 0. So what we're going to do here is we're going to have a limit. I know how much you guys love those. The limit of what? The limit of f of x plus h minus f of x all over h as h approaches 0. And that is the definition of derivative. That is how you will find the tangent line at any point. And in later videos we will go over this again, and in the next video we will find the derivative of some functions using this. We will find the tangent line. And then later videos we will learn some tricks, and we will start to use them to find the derivatives a lot more easily, so we don't have to come back to this limit definition. But this is the backbone of derivatives. This is exactly what it is. So I hope you learned something. See you next time.